Millions of years ago, a giant space rock slammed into the Earth, wiping out the dinosaurs, changing the planet forever. Thanks to cutting-edge technology, scientists have pieced together a fresh timeline, revealing the true story behind this ancient impact and where it came from. Brace yourself to experience the event that nearly erased all life from the face of the Earth. Roughly 66 million years ago, a massive asteroid hurtled through space and smashed into the edge of what is now the Yucatán Peninsula in southeastern Mexico. The impact unleashed a global catastrophe. Firestorms ignited across continents, towering tsunamis ravaged coastlines, and debris rained from the skies, plunging Earth into chaos. Though the 120-mile wide crater is now buried beneath hundreds of feet of sediment, scientists are still uncovering its secrets. At the site of the ancient impact, researchers have drilled deep into the seabed, cutting through layers of rock and debris blasted out by the asteroid. These core samples offer a window into the past, revealing how the Earth's surface was reshaped in the aftermath. Among the materials recovered from the Chicxulub crater are layers of melted rock and granite pulled up from deep beneath the crust by the force of the impact, and even carbon-rich layers, evidence of massive wildfires that scorched the land. At the time of the impact, dinosaurs ruled the Earth. They had dominated the planet for nearly 200 million years, thriving in a wide range of environments, from dense forests and coastal swamps to open plains. The fossil records suggest they weren't in decline. In fact, many paleontologists believe dinosaurs were still going strong, with a diverse range of species living across the globe. Giant plant eaters like Triceratops and long-necked sauropods roamed the land, while predators like Tyrannosaurus rex stalked their prey. It was a vibrant, active world, one that came to a sudden and catastrophic end when the asteroid struck. Before the impact, dinosaurs roamed the land, hunting and grazing among rich green landscapes. In the skies above, pterosaurs glided, while in the oceans, mosasaurs ruled the waves. On the forest floor, small mammals darted through the undergrowth. It was just another ordinary day in the late Cretaceous, until everything changed. In the final hours before the disaster, what may have looked like a bright star slowly growing in the sky was actually a massive asteroid hurtling towards Earth. It was between 6 and 9 miles wide and racing through space at nearly 45,000 miles per hour on a direct collision course with the planet. The asteroid, as large as a mountain, slammed into Earth's atmosphere with full force, like a boulder striking a puddle, travelling at immense speed. It pushed the air in front of it, creating a powerful compression wave. This wave squeezed the air so tightly that molecules collided rapidly, releasing intense heat. In just seconds, the surrounding air superheated, glowing with energy. But the giant rock didn't slow down. It tore through all 60 miles of atmosphere in only 3 seconds, still moving at full speed towards the surface. The asteroid, bound for the shallow seas off the coast of what is now Mexico, tore through the skies over Central America. The force of its entry unleashed a sonic boom so powerful it would have been louder than anything ever experienced in human history, echoing across every continent. As the asteroid tore through the atmosphere, the intense heat from the compressed air instantly vaporised much of the shallow sea that covered what is now the Gulf of Mexico. Just milliseconds later, the asteroid slammed into the exposed seafloor with unimaginable force. The impact hit bedrock and triggered a violent reaction. The ground itself behaved like liquid, rippling and flowing in waves, much like a double splash from a cannonball hitting water. The collision was catastrophic. The asteroid struck with such power that it punched several miles into the Earth's crust, carving out a crater over 115 miles wide and vaporising thousands of cubic miles of rock. It came close to reaching the Earth's mantle. In an instant, a massive crater rim surged upwards like a ring of mountains 15 miles high, taller than the Himalayas. As the massive unstable peak collapsed under its own weight, it reshaped the crater, flattening the centre into a broad, shallow basin, and formed a central peak known as a peak ring. The energy released on impact was staggering, making it more than 4.5 billion times more powerful than the atomic bomb dropped on Hiroshima. This immense force excites surrounding molecules to extreme temperatures, far exceeding those on the surface of the Sun. The intense heat strips electrons from atoms, transforming the air into an expanding glowing plasma fireball. The intense heat completely annihilated all life forms within the immediate impact zone. Any dinosaurs close enough to witness the event would have been instantly or within mere seconds incinerated. Vegetation like trees, grass and shrubs would have caught fire spontaneously. Following the heat came a powerful shock wave, roaring outwards at speeds exceeding 1,000 miles per hour. Dinosaurs would be vaporised in what is now Central America, deafened by the blast in North America, and faced hurricane-force winds as far away as Canada. The massive burst of kinetic energy unleashed by the impact sent shockwaves rippling through the Earth's crust. These seismic waves triggered colossal earthquakes and volcanic eruptions, so powerful their effects could be felt on the opposite side of the planet. The impact unleashed gigantic tsunamis, sending mile-high waves surging across the ocean. These waves were powerful enough to scour the sea floor for thousands of miles from where the asteroid struck. No coastline was spared. Tsunami waves raced across the oceans, crashing into shores and wiping out everything in their path. Within an hour, the massive tsunami waves had surged beyond the Gulf of Mexico, sweeping into the North Atlantic. They funneled through the ancient Central American Seaway into the Pacific and eventually reached the Indian Ocean from both directions, spanning nearly the entire globe. The few animals that survived were those with special advantages, creatures that could swim, burrow underground. These included crocodiles, turtles, deep-sea organisms, lizards and some early birds. But very few four-legged land animals over 25 kilograms in weight made it through the devastation. When the asteroid slammed into the Earth, it blasted nearly 25 trillion tons of rock and debris up into the atmosphere. Much of this material was launched at super high speed trajectories, even fast enough to escape Earth's gravity entirely. Some of the debris escaped into space, scattering across the solar system. But within an hour, most of the debris rained back down, forming glassy fragments known as tektites. These fell at speeds between 100 and 200 miles per hour, showering the planet like flaming bullets. As they re-entered the atmosphere, these tektites emitted intense thermal radiation, enough to ignite wildfires across the vast stretches of land. It's believed that up to 70% of the Earth's forests were consumed in the global inferno, further heating the Earth's surface and fueling the destruction. The animals that made it through the calamities shared one key trait: the ability to escape the intense heat. Some took refuge underground, others swam to safety. Small mammals that were able to burrow or hide in sheltered places stood a better chance of surviving. Reptiles like crocodiles and lizards, with their semi-aquatic habits and burrowing behaviour, also endured. Many ground-dwelling birds also managed to survive, while species that relied on trees were wiped out in the massive forest fires that followed. Here's the great twist in the story. What truly doomed the dinosaurs wasn't just the size of the asteroid or the force of the blast, it was where it hit. The asteroid struck a region rich in sulphur and oil, due to the area's unique geology. The sedimentary rocks there especially were loaded with sulphur, which played a critical role in what followed. Enormous amounts of sulphur and vaporised water were blasted high into the atmosphere. As the sulphur mixed with water vapour, it formed clouds of sulphuric acid and rained down across the planet. This acidic rainfall devastated plant life on land, disrupting the very foundation of the food chain. At the same time, it began to acidify oceans, lakes, rivers and ponds, wreaking havoc on the ecosystem. The asteroid didn't just vaporise rock, it also unleashed vast amounts of oil locked within the region's sedimentary layers. In fact, the Chicxulub crater was uncovered much later during oil exploration. The intense heat from the impact ignited this oil, sending thick black soot up into the stratosphere. This released huge volumes of carbon dioxide, intensifying a greenhouse effect. But what followed was even more catastrophic. For the next 3 years, sunlight was blocked by a shroud of dust and soot high in the atmosphere. Temperatures plummeted and photosynthesis ground to a halt, bringing ecosystems and food chains across the planet to the brink of collapse. This event triggered a dramatic cooling period, causing global temperatures to plummet by nearly 50 degrees Fahrenheit. The average temperature across the planet fell to just 12 degrees Fahrenheit, resulting in extremely harsh and unforgiving conditions. However, a few tropical regions, specifically Madagascar, India and Indonesia, escaped the worst of the freeze due to their equatorial location at the time. The asteroid impact is believed to have wiped out all the dinosaurs except for their bird descendants and most of all the animal and plant species on Earth. A small number of animals, however, managed to survive these extreme conditions against all odds. Crocodiles, for example, proved incredibly resilient. These tough reptiles are built to endure thanks to their low metabolic rates, which allows them to go long periods without food. Their ability to live in various aquatic habitats and dig burrows gave them safe refuges during the worst periods. Turtles also pulled through, likely due to their capacity to shelter in burrows or underwater, and withstand harsh environments, with their compact size which made survival more manageable. Reptiles like lizards and snakes endured as well. Their survival is often credited to their small size, ability to take cover underground or in water, and their highly adaptable diets. In the deep ocean, life endured too. Many deep sea creatures were shielded from the chaos on the surface. Their environment remained relatively stable, and the slow, steady fall of organic material from above provided just enough food to sustain them. Some small mammals also made it through the catastrophe. These early survivors were among the first to return to the trees once the forests began to regenerate. Their flexibility, burrowing habits, varied diets and adaptability played a crucial role in their persistence. And then there were birds, the final feathered legacy of the dinosaurs. Their ability to fly, coupled with their diverse food sources and small size, may have given them a unique edge. Today, they stand as living proof of nature's incredible ability to adapt and endure. The asteroid that wiped out the dinosaurs likely came from the outer reaches of our solar system. Scientists believe the asteroid responsible for this mass extinction was a type of primitive, ancient asteroid that formed over 4 billion years ago during the early days of the solar system. These specific types of asteroids are typically found far from the Sun, in the colder regions beyond Jupiter. The fact that the asteroid matches this composition strongly suggests it originated from that distant region, and after drifting through space for eons, it eventually made its way towards Earth, setting the stage for one of the most dramatic mass extinctions in our planet's history. According to scientists, Earth only takes a hit from asteroids this size every 250 to 500 million years, so no need to duck just yet. In a surprising discovery made in 2022, researchers revealed the existence of a massive crater hidden beneath the Atlantic Ocean just off the coast of West Africa. This formation, known as the Nadir crater, spans an incredible 5.5 miles in diameter and is believed to be the result of a powerful asteroid impact. What makes this finding especially intriguing is its age. It appears to date back roughly 66 million years ago, around the same time as the infamous Chicxulub impact in present-day Mexico, which triggered the mass extinction of the dinosaurs. Some scientists suggest the Nadir impact might have come from a fragment of the same asteroid, potentially pointing to a double impact event. However, the evidence is still inconclusive. The exact timing and connection between the two impacts remain uncertain, as more precise dating is needed. While the Nadir crater is much smaller than Chicxulub, it would still have caused significant destruction in the region. Fortunately, scientists are now testing the world's first real planetary defence system, NASA's DART mission, designed to steer a spacecraft directly into an asteroid and alter its path. This mission marks a turning point in our ability to defend Earth, showing that for the first time, we're not just observing space, we're ready to act. That's all for now. Stay connected and thanks for watching.